Hello friends, Jim here with Science Talk, and I want to share with you some new studies that looks at the jet stream. Now, for those of you who have seen my videos, I discuss what's going on with the jet stream, and that's a new hypothesis that's being examined, that i.e. climate change does affect the jet stream and will impact weather patterns around the globe. And if you watched my video series on oscillatory systems, especially the North Atlantic Oscillation, the Arctic Oscillation, the Arctic Dipole videos, I mentioned about how the jet stream is being affected. And we are definitely seeing signs of that. We're seeing a couple of things going on. The jet stream is changing its flow mainly from a zonal flow, which is what it used to be, to a more meridional flow. So now zonal flow it follows latitudinal lines, go kind of like in a band, just go whipping around the planet. Meridional is where it does ups and downs, kind of dipping. And when it dips, it could bring cold Arctic air down to lower latitudes. On the same token, it could bring warmer tropical or subtropical air to higher latitudes. But what happens is that the temperature and pressure gradient not as extreme. The jet stream slows down. And if you have a low pressure system, for example, that's riding the jet stream and it's going slower, if it's got a load of precipitation, it can do what? It can linger and dump considerably more precipitation than has been historically typical. And we're seeing this. This is being demonstrated as happening, and definitely a ramification, a consequence of humans changing the planetary climate system. So, German scientists have identified and implicated the jet stream as to, feeling a little chillier than usual, a little hotter than usual. And they basically say, blame it on Arctic warming. So what happens in the Arctic doesn't stay in the Arctic. It does affect the whole planet. And the Arctic is the fastest warming region on the planet. The retreat of the sea ice over the polar ocean has distorted the pattern of flow of the stratospheric winds, jet streams, and sometimes called the polar vortex, which we see in the, if you look at what is examined in the NAO and the AO and the AD, Arctic Dipole, when you look at their indices, is it on the positive or the negative phase? This is one of the things that's looked at, that included in the calculation of the index. And I just did a bunch of videos, and I probably got more coming because more data comes in, of the crazy summer that was here in Alaska. Sea ice at one of its lowest amounts ever, highest ocean surface temperatures, sea surface temperatures, SST, record-setting air temperatures, one of the hottest summers for the entire state of Alaska overall, with some regions the hottest summer ever. It's just been insane up here. And then we turn around and go from extreme heat, wildfires, one burning less than 20 miles from my house, to just pissing rain nonstop, where we're setting record rainfall in 24, 48 hours. August is typically the wet month in interior Alaska. And, typically we might get 4 to 5 inches over the month. Some places are getting that in 2 days. Things like the rest of the month to deal with. It's just been crazy. That's climate change. So what did the scientists do? And by the way, this is a report that was published in the journal Scientific Reports. They actually employed artificial intelligence and a machine learning program to accurately model the changes in the jet stream and then link these to changes in the chemistry of the upper atmosphere. Now, this is an interesting approach. And then they also looked at the increasing patterns of the atmospheric motion, twisting waves, if you will, of the high altitude winds, which can distort seasonal weather in the northern hemisphere mid-latitudes. So Marcus Rex, who heads the atmospheric research at the Albert Wegener Institute in Potsdam, Germany, okay, he was the lead investigative scientist. Our study shows that the changes in the jet stream are at least partly due to the loss of Arctic sea ice. If the ice cover continues to dwindle, we believe that both the frequency and intensity of the extreme weather events previously observed in the middle latitudes will increase. And this is very important. In addition, our findings confirm that the more frequently occurring cold phases in winter in the USA, Europe, and Asia are by no means a contradiction to global warming. Rather, they are part of anthropogenic climate change. So let me repeat that. The occurring cold phases in winter over the US, Europe, and Asia are by no means a contradiction to global warming. Rather, they are part of anthropogenic climate change. So when you hear idiots say, well, it's cold here, it can't be global warming. It's snowing a lot, it can't be global warming. They don't know squat. The study is showing this. More snow means there's more moisture in the air. The warmer the air is, the more moisture it can hold. Earth Science 101. That's 9th grade science, for goodness sakes. Now the jet stream, which, jet aircraft, going back and forth between North America and Europe constantly use, is made up of westerly winds, it blows west to east, at an altitude of 10 kilometers, and they move around the planet about mid-latitudes up to speeds of 500 kilometers an hour. And they push the weather systems along with them, west to east. Well, as I just mentioned earlier, going from zonal to meridional. So researchers have already observed this. This is what they have already observed. They have been changing in response to global warming, and in particular to the rapid warming of the Arctic. As greenhouse gas ratios in the atmosphere rise and go on rising. So it's not just CO2, it's CH4, methane, and a new hazard that I reported on some time ago, and you can check out my video on that, NO2, nitrous oxide. Nitrous oxide is being emitted from the thawing permafrost. A new hazard. Rather than stick to a course more or less parallel to the equator, these winds have been observed describing dramatic waves. Meridional, dipping up and down. These twists of direction have been linked to blasts of Arctic air into regions that could normally expect relatively mild winters. And they point to the ferocious cold that hit the U.S. Midwest in January 2019, where places like the Dakotas were considerably colder, and Dakotas do get cold, but they were considerably colder than Alaska. I was seeing reports where places are getting minus 20, that usually 20 above is cold, and we're sitting here at 5, 10 above. These winds have also weakened and been linked to prolonged drought and extremes of heat that hit Europe in 2003, 2006, 2015, 2018. This again ties into what I said earlier about the gradient, be it pressure and or temperature, not as strong, not as defined. But of course, like everything else, this association does not demonstrate a cause and effect. The Potsdam scientists wanted more positive evidence to demonstrate cause and effect, and their new climate simulations now include accounting for ozone chemistry at high altitude. And I have to say that this caught me by surprise. So looking at the chemical, I mean, let's say I'm basically a fluid dynamicist, so I think in physical processes. I don't always consider or take into account necessarily chemical behavior itself. I may look how the physics distributes the chemicals, okay? How physics affects, say, whether it's hydrodynamic flow or aerodynamic flow. So this is interesting for me. What their new model found is that as the Arctic sea ice retreats, the atmospheric waves have warmed the polar stratosphere in ways that have been amplified by the behavior of the ozone layer. So now let's look at the ozone response. Since what powers the jet stream is the difference between the cold Arctic and the warm tropics, the jet stream has weakened, right? Pressure gradient and temperature gradients are less, not as well defined. And they've begun to meander. This is that meridional flow. I'm basically taking verbiage from their studies here. In fact, a new study introduces a new place to the climate puzzle, the response of the ozone layer and its role in the play of winds around the planet. Now, they're not quite sure what the mechanism is just yet, but the continued research should hopefully elucidate this. So Professor Rex has said, we are now for the first time employing artificial intelligence in climate modeling, helping us arrive at more realistic model systems. Now, I'm guessing using AI allows for 24/7 continual monitoring and updating of the program, and at a lot faster speed than humans can do. This holds tremendous potential for future climate models, which we believe will deliver more reliable climate projections and therefore more robust basis for political decision making. Yes, let's get those politicians get their asses in gear. So this is interesting. So, we've got evidence that this is happening. Has the cause and effect been demonstrated? Probably not to everyone's satisfaction, but certainly is strong enough evidence to indicate, yes, that this is the case. Now, if this ozone approach helps deliver this cause and effect, that's great. And I look forward to seeing where they take this research and how they present their findings. It will be interesting to see what the mechanisms, as they come to understand it, are and how that mechanism basically defines a cause and effect. Of course, this will require statistical analyses, mathematical analysis, etc., etc. But we definitely said this is a new hypothesis that global warming will lead to changes in the jet stream. We're now collecting the evidence that indicates this is indeed the situation. So now the next step is to solidify the science to demonstrate cause and effect. Now, of course, we can look at the NAO, the AO, and the AD, and we are, and we look at that, and we can look at what the jet stream is doing compared to historical data, etc. We collect the temperature gradient, the pressure gradient, etc. Now let's go and try and pull this all together. This is something that's only been within the last decade or so. So a lot of work, complex system, but I'm pretty positive that this will be pulled together and cause and effect will be demonstrated, which is a lot nicer than association. Causation is nice. We like causation, cause and effect in science as opposed to association. Be that as it may, if they can demonstrate cause and effect, then this will confirm the hypothesis, and then this can be further tied back to human activities. So I think this is quite exciting, from a scientific point of view, the research. And let's see where this goes. So this is something I'm going to keep on top of, and as their new results are published in the journals, I will bring those results to you. Thank you for your time. Hey folks, it's a reminder to please share my videos with others, and to also please tell others of my channel. Please subscribe, and don't forget to hit the bell so that you receive notifications when I upload new videos. I also hope that you will consider supporting the work that I do and supporting this channel by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.